Hi. So our course is about logic design. We have seen the first chapter, just introduce you what logic design is. Now we will be examining, this is the second chapter, we will be examining Boolean algebra. Boolean algebra is the mathematics that we're going to use in digital design course. So this chapter has got two sub-chapters, Boolean algebra and Boolean functions. So we're going to examine the Boolean algebra first. In Boolean algebra, we've got 5 frames. For each frame, there's going to be a video. What we're going to see in here, the basic concepts. One of them is the relation, because the relation is the beginning of everything. Based on that relation, we're going to talk about the basic concept function, the number of functions that we can define on finite sets, Boolean algebra axioms, and Boolean algebra theorems. So in order to give the axioms, I need to explain these basic relations first. So this altogether there's going to be 5 videos, as I said, 1, 2, 3, 4, 5. So this one is related to these basic concepts. So let's come out of this presentation and shift to open board. Okay. Let me clear this area first. So beginning of mathematics start with sets, of course, you know that. Relation between the sets is the second basic concept. In order to define a relation, we need to know what Cartesian product is. Cartesian product, let me read it directly and then explain it later on. Cartesian product of two sets x and y, denoted x multiplied y, is the set of all possible ordered pairs whose first component is a member of x and whose second component is a member of y. So x Cartesian product y is equal these pairs, all possible of them. The first of this pair is going to belong to x, the second is going to belong to this y. This order is important. Conclusion is this: x Cartesian product y is not the same set of y Cartesian product x, because the order is changing, isn't it? So in this one, the first element is going to belong to that y. That's why you can't do that. So this is not true. So once you find the Cartesian product of two sets, Cartesian product of two sets, any subset of this Cartesian product is called relation. So for this one, so I should have written this like that. So we change x and y now to this a and b in here. So any subset this then. So let me show you how you're going to find this subset. Let's say set A includes A and B, set B includes C, D, E. Then A Cartesian product B is equal A, C, A, D, A, E, and then B, C, B, D, and B, E. So this is orders. You see here these pairs. The first element of these pairs belongs to A. The second element belongs to B. So all the possible ones, there is no any other pair like that. So all the pairs are included. So this is the Cartesian product. Any subset, for example, if you say that AC, B, so this is a relation. Now, this is a relation. In Turkish it is bağıntı. So we are saying if this relation has got some properties on it, we give them some special name. Equivalence relation, for example, has got those three properties. It is a reflexive, it is symmetric, and it is transitive. What we mean by saying reflexive, so if the relation is defined on the same sets, so in here x and y, they are different sets. Now we are saying if the relation is defined on the same set Cartesian product. So that means it is like that. Subset of this Cartesian product, if it has got these three parameters, then it is called equivalent relations. So one of them is this. For each A in this set, this A and A must be in the subset relation. If AB is in the subset relation, then BA should also be in subset relation. That's symmetric property. And transitive relation, maybe if you read this one, that's easy to understand. If AB belongs to R, subset relation, and BC also belongs to R, then AC must also be inside this relation. If those three properties are included in a relation which is defined on this set A, then this relation is called equivalent relation. In mathematical, what is this in what mathematical operation? Equal is this operation, isn't it? Equal, when you say equal, you are mentioning about this relation. The another relation is the one similar to this one, so you are defining the relation on set A once again, Cartesian product of A, and if the subset of this Cartesian product of this has got those three properties, not including the reflexive property, then it is called order relation. Order relation is important. Why is that? For example, real numbers is a order set, isn't it? 1. So you can make an order like that. Time in physical, time is an order relation. In our life, what is order relation? Is planning, isn't it? If you say that I am going to do this first, wake up first, wash my face is second, that's an order relation, isn't it? So planning your life is also an order relation. So if you make an order relation like that, that means you have chosen your preferences. This order relation changes your whole life. Any value that you have determines that order relation, isn't it? Your behavior changes according to your selection of the values, important values. So that means you're going to spend your life, your time, for this value. So that means when you do that, so that means you are planning your life, so your life becomes an order relation, isn't it? So due to time, life is order relation. How you're going to spend your life is your decision, and it includes a order relation as well, according to your values. If you say value A is important, so that means your preference to do that value related event has got preference, so you're going to do it first. you're going to do it first, that's order relation, isn't it? So that's the end of this relation. We put a bit of life in it as well. So let's stop now.